first phase of the workflow is the concept phase. We're going to look at how Creo can help your customers conceptualize their designs. Repeating things for decades doesn't make them true. For more than 50 years, people thought CAD was an acronym for Computer-Aided Design. It's time to face facts. It really stands for Computer-Aided Documentation. The computer doesn't aid your design. The design is in your head, and you just use the computer to document it. What's been standing in the way of real computer-aided design all these years? It's the way people always use computers as passive tools for execution, waiting for people to tell them what to do. So how can the computer be used for something more? How can it become a partner in exploration? The newfound abilities of computers to be more creative and learn are making this idea a reality. Computers that creatively produce ideas on their own are the heart of generative design. In generative design, you share your goal with the computer. Tell it what you want to achieve as well as the constraints involved, and the computer explores the solution space to find and create ideas that you would never think of on your own. In this initial concept phase, Creo's generative design capabilities, GTO and GDX, provide a consistent UI and make it easy to define the generative design geometry, set up the optimization, and then rapidly solve for the optimal design based on the specified criteria. Let's look at the video demonstrating Creo's generative capabilities.
This video shows the process that is required to define the generative design setup and run the generative design optimization. The first step is to define the design spaces. Design spaces include starting geometry, preserved geometry, and excluded geometry. After the design spaces are defined, the next step is to define the physics. Physics are the constraints and loads that are defined to simulate real-world conditions. Generative design provides the ability to define multiple load cases to capture different load case scenarios. When the generative design optimization is performed, each load case will be considered, not as a cumulative load case, but as separate load case scenarios. The resulting geometry is created to satisfy all load cases. In this example, we define two separate load cases, defined as structure 1 and structure 2. When defining multiple load cases, users can ensure designs are created to satisfy different usage scenarios and operating conditions. The next step is to define the design criteria. Design criteria can include a number of user-specified criteria, such as limit volume, manufacturing process information, symmetry, spreading, material properties, and other options that will be considered for the optimization. The final step is to run the optimization. When the optimization icon is selected, generative design will begin the process to create the optimal design, solving for the user-specified criteria and design goals. In this example, the optimization was solved in just 24 seconds. When the optimization is finished, the user can review the simulation results to evaluate and validate the stress and displacement for each load case. When visualizing displacement, the user can select the option to animate the model deformation when viewing the results. When satisfied with the results, the user can choose to save the faceted geometry or use semi-automated reconstruction from facets. In this example, we will choose to save the faceted model to a separate file. The faceted results will be used as reference information to reconstruct a clean model. Manufacturing production method and production volume will determine how the model is reconstructed.
Let's check your knowledge. Select all that apply to Creo's generative design capability. Creo's generative design provides a consistent UI and allows the user to define the generative design geometry, set up the optimization, and solve for the optimal design based on the specified criteria. We'll continue with design.